yeah, you need to press pretty hard. Like if you press hard, let's try let me be here. That might work. Okay, and you just flip it here and you should turn green. There you can see that on the side. Okay. All right. Next up, we're going to have Cairo and Giuseppe talking about Kubernetes, rootless Kubernetes.
Hi all, thank you for coming to our talk. In this talk, we will show how we can run Kubernetes and its dependencies such as CRI and OCI runtimes as an unprivileged user on the host. I'm Akihiro Suda. I'm a software engineer at NTT Corporation. I'm a maintainer of Mobi, which was formerly known as Docker Engine. I'm also a maintainer of BuildKit, Containerd, and some small container-related projects.
And I am Giuseppe Scrivano. I work for Red Hat. I work on different projects related to containers, but my main focus is on the projects listed there.
Let's start with a demo. On this node, my username is a user and UID is 1000. It's not a root user. I don't even have sudo. And on this host, I'm running everything as an unprivileged user. So you can see Docker D. The Docker demo is running as an unprivileged user. You can also see Kubernetes is also running as an unprivileged user. And even flanerd is running as an unprivileged user on the host to provide multi-node networking using VXLAN. And my cluster is my cluster is composed on Containerd node and Docker node and CRI node. All of these nodes now support rootless execution. And I'm running some NCX pod on this cluster. And we have multi-node networking as well. So I run SH shell on this first one. And I can do wget against the node container on other node, like 10.580.3. Like this, it works. So the introduction to rootless Kubernetes. So when we refer to rootless Kubernetes, we mean we run everything as an unprivileged user. It's not just about running containers as an unprivileged user. So please do not confuse with security context.run as user, which just run container as an unprivileged user, or node level user namespace, which is going to be added in Kubernetes 1.14. So we literally run everything, so including OCI runtimes, such as runC or CRI runtimes, such as Containerd or CRI as an unprivileged user. Of course, we run Kubernetes, kubefluxy, kubeAPI server, kubescheduler as an unprivileged user as well. So the motivation of rootless Kubernetes is to mitigate potential vulnerability of OCI runtimes and CRI runtimes and Kubernetes itself. Actually, we had a very bunch of vulnerability in Kubernetes. Also, the rootless Kubernetes is useful for users of shared machines such as HPC to run Kubernetes without risk of breaking other users' environments. The rootless Kubernetes is also useful for running Kubernetes on top of existing Kubernetes clusters. So actually, Kubernetes had a lot of vulnerabilities. For example, 2 years ago, a couple of vulnerability was found. It allowed a malicious container to access the host file system via some vulnerabilities related to volumes. And last year, there was a Git CVE that affects Kubernetes via Git repo volumes. So a malicious repo could execute an arbitrary binary as the root on the host when the repo was cloned. Also, last year, there was a serious vulnerability in Kubernetes that allowed malicious API clients to gain cluster admin and hence the root privileges on the nodes. And also, just a couple of weeks ago, we found and analyzed the serious Minikube breakout issue. So on the Minikube, malicious container could gain the right access to procfs and sysfs because on the Minikube, the host root file system is init.rd. So you can gain right access with these unshared command and mount commands. And you can execute any command as the root on the host via a proxys kernel core pattern or syskernel U event helper. So how rootless Kubernetes works?
So namespaces are the kernel feature that allowed us to have containers. They give a process a different view on the system. The most important one for enabling the rootless case is the user namespace. It basically gives a process the idea of running with a different UID and group GID that in reality is running for the kernel. An unprivileged user can create a user namespace, but it can only map itself inside of It can only map itself inside of the new namespace. So this is not enough for us for running images that requires multiple users. The user in the namespace can have a UID 0, but and full capabilities, but these are restricted by the kernel. So in general, the same limitations that he had as running on the host will still have in the namespace. So for allowing multiple UIDs, we use two tools distributed by Shadow UT, and new ID map and new GID map. This allows to an unprivileged user to map multiple IDs inside of a user namespace. So so we can see that the configuration for the multiple IDs is done through the etc sub-ID file. So for user ID 1000, we allocate 65,000 additional users. So when we create the user namespace, we can see that there are two ranges of users. The first one is the user itself is mapped to root inside of the user namespace, and then each additional ID specified in the configuration file, it's also added to the user namespace.
With recent kernel, unprivileged user can also create network namespaces along with user namespaces. So an unprivileged user can create IP tables rules and also configure BXLAN, and also they can isolate abstract Unix sockets. So, but this wasn't very useful because an unprivileged user still cannot set up virtual Ethernet pairs across the host and namespaces. That means rootless containers couldn't connect to the internet. But this is not a problem because instead of virtual Ethernet pair, we can use user mode network stack called SRAP. And there are a couple of SRAP implementations such as BDE plug, BBN kit, and SRAP for NetNS. Among these three implementations, SRAP for NetNS is the fastest. Especially when the MTU is about 64 kilobytes, SRAP for NetNS can reach more than 9 Gbps throughput. This is still slow compared to the rootful virtual Ethernet pair, which can reach more than 50 Gbps. But we consider 9 Gbps is enough for a lot of use cases. SRAP for NetNS is the fastest because it avoids copying packets across the namespaces. We also plan to add more optimizations. And we can also set up multi-node networking. Currently, BXRAN is known to work. BXRAN encapsulates Ethernet packets in UDP packets, so it can provide layer 2 connectivity across rootless containers on different nodes. Other protocols should work as well, except ones that require access to raw Ethernet. So probably GRE is not likely to work.
So the container for being used needs to have its storage configured, and it needs to live somewhere. Many of the file systems that are used for containers running as root are not usable for rootless. Ubuntu allows overlay FS in a user namespace, but this is still not supported upstream as there are some security concerns about opening it for unprivileged user. But RFRS can also be used by an unprivileged user, but it requires to be configured before. And the device mapper is completely unreachable for a rootless. The simplest solution is just to extract the image as it is. For each container, you duplicate the entire image, and this is known as the VFS backend. This works, but we lose all the advantages of the duplication we have with overlay. This can be improved using ref links on file system supporting them, so that at least the same files share the same payload. But still, we need to create inodes, and this is as a cost if you have many containers. A nice feature that was added to Linux 4.18 is that it's possible to use Fuse file system in a user namespace. So we implemented basically overlay in a user space. It's Fuse overlay FS. It's a Fuse implementation of overlay. It brings in all the advantages of using overlay, so we have the same deduplication model based on layers. It's very fast to set up a container because we basically need to create an empty directory, and that's but it brings also extra complexity. It's a new implementation. He had a few issues in the last month. And in general, I consider it a temporary solution until overlay from the kernel is usable. So this was just to not stop us for using overlay for now. C groups is still the biggest problem we are having. C group V1 is not considered safe for being used by unprivileged users. The delegation model there it's not considered safe. C groups version 2 will solve these issues, and it can be used by unprivileged users as well. But still, its adoption is blocked in the current OCI tools. It's lacking some features that are still used by the runtimes.
The next is implementation status in Kubernetes. Actually, Kube API Server, Kube Controller Manager, and the Kube Scheduler doesn't need any patch. But kubelet and Kube Proxy needs to be patched because currently C groups need to be disabled. And also some of sysctl course needs to be disabled as well. And we are planning to propose our patch set to Kubernetes Signal soon. With regard to CRI runtimes, both CRI and Containerd already supports rootless mode. It's not supported by Docker at the moment, but Docker version 19.03 is very likely to support rootless mode. And with regard to CNI plugins, Frontend BXRAN is known to work without any modification. We also plan to work on kubeadm integration as well. And we provide usernetes, which is experimental binary distribution of rootless Kubernetes that can be installable under user's home directory without mess. So you can just download a binary archive from github.com/rootless-container/usernetes and just unpack the archive and just run run.sh. And you can do kubectl without mess. And we also provide Docker compose.yaml for demonstrating shared multi-node cluster of rootless Kubernetes. The cluster is composed of Docker Sim node, CRI node, and contrary node. And the front-end VxRun is enabled by default. But this cluster is just proof of concept status, especially TLS is not enabled it in this cluster. So we welcome contribution. We also plan to provide Kubernetes YAML for deploying Kubernetes on top of existing Kubernetes cluster. Any questions?
Thank you. What if you want to run one Kubernetes pod with full privilege? Is it possible, or is it prevented by using Kubernetes?
Sorry, could you repeat your question?
If you want to run one pod with full privilege as root, is it possible, or is it like to run Kubernetes as user and Docker as user, etc., except one pod with privilege?
No, because it's running as the unprivileged user. So running as root still means that for the kernel you're running like your unprivileged user. So when we run Kubernetes, there is no access to any root capabilities. Everything is restricted by unprivileged user namespaces.
Thank you. We provide Kubernetes pods to developers, but we forbid sudo access. How easy is this to replicate, and can this be used to give developers sudo access, for example, for sudo apt-get install?
You don't need sudo when the host is properly configured. So basically, the host just needs to have a sub-UID file. This file needs to be configured by the real root on the host. If this file is configured, you don't need any sudo. You just unpack the archive as an unprivileged user, and you can just run cluster as an unprivileged user.
I want to add one thing. We tried really hard to not require any root privilege for running Kubernetes. The only exception is, as I showed before, it's with setting up multiple IDs, and this is something just an unprivileged user can't do. So that's the only case where we require a setuid binary. Any other question? Yeah. What's the local 418, at least, yeah.
Hi. So I saw in the demo that you were doing wget to an IP, I guess a node IP, and I guess that there was a service configured there. Listening on port 80, I wonder how you did that without having root for using IP tables or that.
How you communicate with other pods on the demo? How you communicate between two pods on the demo without requiring root? They are using the unprivileged network we configured as unprivileged user. This is it's on top of the network namespace as root. We can the demo that you showed was running in a virtual network, so and all of it was running as unprivileged. I guess that's all. Thanks for coming.